Hello everyone, welcome to Exemplar Physics. In this video, we are going to deal with the topic refraction of light. These questions are for practice and at the level of class 10. You know what? These questions were sent by one of you. If you too have any doubts in any concept or you are facing difficulty in solving questions, send them to me. I will try to make a video solution as soon as possible. If you haven't studied this topic yet, don't worry. Only thing is you need to watch the video till the end. While solving each and every question, I'll be telling the concept, tips, trick and easiest way to solve the questions. So before starting the video, let's understand what is refraction. Refraction is the phenomena shown by light when it travels from one medium to another medium. Let us see the picture here. Here we have air and the light is traveling in the air. So you can see the light is traveling straight. But as soon as it comes near this point, that is a point on the interface. Interface implies it is the boundary between the two media. Here we have two media here. The outside media, that is air, and inside this is a glass slab. Hence it is glass. And again at the inside the glass the light travels straight, and when it reaches the interface, that is now when the light is traveling from glass to air, again it bends and then again goes straight. So in this you have observed that light is bending whenever it is passing through the boundary between the two media. And this phenomena is called as refraction. Remember, refraction happens only when the light hits on the interface obliquely, that is at an angle between 0 and 90 degrees. We are excluding both 0 and 90. Here I am indicating I as angle of incidence, and the angle of incidence on the boundary, that is the interface, should be between 0 to 90 in order to observe refraction. So you can observe that light travels in a straight line until it passes through the interface obliquely. So with that knowledge, let's try to solve the questions over here. The question says, calculate the speed of light in water if the refractive index of water is 4/3. Given the speed of the light is 3 into 10 power 8 meter per second. So let's write given first. The data which is given in the equation are: number 1, the refractive index of water. So I am writing refractive index. I am denoting refractive index with Greek letter mu. In some books it is also written as n. So I am writing mu w. It means you have to read it as refractive index of water. And how much is that? 4/3. Given speed of light in air. Speed of light in air I am denoting with letter c. And how much is that? 3 into 10 power 8 meter per second. And what are we supposed to find out? We are supposed to find out speed of light in water, which I am denoting as Vw. So this is what we are supposed to find out. Now you must be wondering, what is refractive index? So the refractive index, let me explain refractive index. Suppose this line is the interface between two media. So say outside is medium 1, the inside is medium 2. So when the light travels from medium 1 to medium 2, it will not go straight. It is going to bend. And bend by how much extent? That can be known by the term refractive index. Now let us take the first medium as air and the second medium as some any other medium. So let that be M. Now if the refractive index is more, that implies the bending or refraction phenomena is also more, and vice versa. That is, if the refractive index is less, the bending phenomena, that is refraction, is also less. Now how does this number come? So as per the definition of refractive index of any medium is written as ratio of speed of light in air divided by speed of light in medium. This is also called as absolute refractive index. We'll come to that later. So mu m, here in this case this will be mu water. So speed of light in air denoted by C, speed of light in water we are writing it as VW. So this ratio is called as refractive index, C by VW for water. Now remember one thing, speed of light is maximum in air, and whenever it goes to another medium its speed decreases. Now see the ratio, C divided by Vm. So the numerator is greater than the denominator and it is equal to 1 if its numerator and denominator both are same. That is, the body moving in the same medium. If the body is moving in the same medium, there will be no refraction. Hence, greater the value of refractive index, greater will be the bending or the refraction. If you have understood that small part, now let us solve this question here. We can write, we want velocity of water, so we'll send the velocity of water to the other side and we get V water is equal to C by mu W. Now let's put the values. C is 3 into 10 power 8 and refractive index of water is 4 by 3. Let us write this properly. So 3 into 3 divided by 4 into 10 power 8. So what do we get? 3 3s are 9 by 4 into 10 power 8. So if you calculate it, if you cancel that, 4 1s are 4, 2s are 8, 1 0, 4 2s are 8, 2 0, 5. So you'll get 2.25 into 10 power 8 meter per second. This is the result or velocity of light in water. Now if you have understood that, let's go to the next question. The next question is, a ray of light passes from air to glass. Here n is equal to 1.5. What is n? Just now we have studied n is also used to represent refractive index. So I am writing refractive index as mu. If you want, you can write n, not a problem. Here the light is traveling from where to where? Air to glass. Hence this is refractive index of glass. How much is that? 1.5. Next, when it is passing, its angle is 30 degrees. This is called as angle of incidence, and I'll write angle of incidence as I. Now we have to calculate what is angle of refraction. Now how to measure angle of incidence and angle of refraction? For that, look at the diagram. In the diagram, you can see this is light, this is incident ray. This point is point of incidence. So if I write this, if I name this as P and the point of incidence as O, PO becomes, PO is my incident ray, that is the ray falling on the interface. So let us name the interface as x, y. The boundary between, say according to our question, outside medium is air and inside medium is glass. Hence the interface xy is the boundary between air and the glass. Now in order to write angle of incidence, what we need is we need to draw an imaginary line. The imaginary line is drawn in such a way that it is perpendicular to the interface at the point of incidence. That is very important. So this imaginary line MN, which is perpendicular to interface at point of incidence, this line is called as normal. Normal is like a reference line. All the angles are measured from normal. Remember, normal is imaginary. So the angle between the incident ray and the normal, this is called as angle of incidence. And similarly, another angle which is from normal to reflected ray or reflected ray to normal, this is called as angle of refraction. So angle of refraction, I am writing it as R. Angle of incidence, angle of refraction, both are measured from normal. If you have understood this, then there are some laws of refraction, like there were laws of reflection. If you remember them, there are some laws of refraction. In that, one law is important here. That law is called as Snell's law. This law has been established experimentally. So we have to understand what is this law. This law says that for a given two media, here what are the media? One is air, the other one is the glass. For the given two media, sine angle of incidence and sine angle of refraction are in fixed ratios. That is, the ratio of sine angle of incidence and sine angle of refraction is constant for given two media, and further this constant is equal to refractive index. Refractive index of what? The refractive index of the medium. Now remember here, the light is traveling from where? The light is traveling from air to glass. So angle of incidence is in air, angle of refraction is in glass. So the refractive index of glass is equal to sine I by sine R. Now what are we supposed to find here? We are supposed to find R. So we know simple mathematics. Let us send sine R to the other side. What is left? Sine R is equal to sine I by mu g. How much is sine I? Sine I is 30 degrees given in the equation, and refractive index is 1.5. This 1.5, I don't like to write numbers in decimal, so what I'll do is I'll write in fraction. 1.5 can be written as 15 by 10 or 3 by 2. I like writing in fractions, it's your wish, any way you can write. So this is equal to 3 by 2. Now sine 30 is 1 by 2 divided by 3 by 2. What are we going to get? We will get 1 by 2 into 2 by 3. This is equal to 1 by 3. So what is established at the end? Sine R is equal to 1 by 3. Now what are we supposed to find out? We are supposed to find out the angle of refraction. So how to get it? You have to find out the value of r for which sin r is 1 by 3. So for this we can write r is equal to sine inverse of 1 by 3. And what is the value of sine inverse of 1 by 3? That will be given in the question. I have used a calculator and you can see its value is around. So if you cannot see the value, let me show it. Okay, now this is sine inverse 1 by 3. So sine inverse 1 by 3 is how much? This is r. Pardon my handwriting. So r is equal to 19.47122063. I'll just keep it to 2 digits. So 19.47 degrees. You don't have to worry about the values of sine. Some basic values like 0, 30, 45, 60 and 90 degrees is enough for class 10th. And if you get any other values like here sine inverse of 1 by 3 and all, those values will be given in the question itself. So no need to worry. So that is writing refractive index from Snell's law. Snell's law says sin I by sin r is equal to mu m. So that's one more concept and one more question completed. Still, if you have any doubts, you can write them in the comment section. I'll make another video in order to make you understand this much better. Now let's go to the next question. The next question says the refractive index of diamond is 2.47 and that of glass is 1.51. So let us write the given first. The first thing after reading the equation we should write given so that we get an idea how to solve the equation. So refractive index of diamond, I am writing it as mu d 2.47 and refractive index of glass is 1.51. Before proceeding, one thing let me tell you. In the first question we have learnt that definition of refractive index of a medium is ratio of speed of light in air to speed of light in medium. So this is also speed, so its unit will be meter per second, and the denominator is also speed and its unit is also meter per second. So when you take the ratio of the same quantities, their units get cancelled out, hence refractive index has no unit. Okay, so what is the unit of refractive index? Refractive index doesn't have any unit. It is just a number which tells us how much the refraction would take place. So with that, though not required, but putting a little more light onto the concept. Now refractive indices are given. Now the question is, how much faster does the light travel in a glass than in diamond? Okay, by looking at the numbers you can just say, check the refractive index. Indices 2.47, the other one is 1.51. Greater the refractive index, greater is the refraction, that is bending. Greater bending implies the speed of light in that medium has decreased. So the speed of light in diamond is less compared to speed of light in glass. You can say it by just looking at the values of refractive indices. Let's go to the definition now. So refractive index of diamond is equal to speed of light in air divided by velocity of light in diamond. Similarly, the definition for refractive index of glass is speed of light in air divided by speed of light in glass. Now since we have understood that, and what are they asking in the question, how faster does the light travel in glass than in diamond, I am going to do an interesting thing. I am going to take the ratio of refractive index of diamond with refractive index of glass and let's see what happens. Refractive index of diamond by definition is C by VD. You can see here mu D is C by VD divided by refractive index of glass. You can write it as C by VG. Now writing the fraction properly, C by VD into VG by C. C and C gets cancelled out. What do we get? VG by VD. So again, let me write the result here. The result we got is mu D by mu G is equal to Vg by Vd. Now one important thing you have to observe here, this is very very important, will help you to solve other questions, not this but other questions. Here you check, in the numerator I have written refractive index of diamond, but its velocity is in the denominator on the other side. Similarly, I have written refractive index of glass in the denominator, but its velocity is in the numerator on the other side. Keep that in mind. And you know what? This term mu D by mu G, this is called as refractive index of numerator. We have diamond with respect to glass. And what is this refractive index of diamond with respect to glass? This is called as relative refractive index. We will discuss this little later. So let's complete this question. Now what are we supposed to do? They are asking velocity of glass. So let us keep glass on one side. And take Vd to the other side. So what do we get? Mu D by mu G into Vd. What is mu D? Mu D is 2.47. And what is mu G? Mu G is 1.51 into Vd. Now we have two numbers and we have to divide them. So what I will do is, I will just take little bit small approximation, please. And this small approximation may not affect the answer that much, just in order to solve the question faster. Otherwise you have to do is take what you have to do is you have to divide 2.47 with 1.51. I am just taking small approximation. 1.51 is almost equal to 1.50. That's it. That's what I am taking here, approximation. Just instead of writing 1.51, I am writing 1.50 to make the calculation easy. I know the answer will be slightly deviated, but I will get almost the correct answer. So that's why I am doing it. Now let us remove this decimal points over there. So we will get 24.7 divided by 15 into Vd. If you are feeling difficulty in this, you do in a normal way, normal division with 1.51. So let's cancel it with 5 table. 5 3s are 5, 4s are 20, remainder 4.47. 4 9s are 45. So remainder 204. Now I can cancel it with 3 1s are 3, 1 9, 3 6s are 18, 1 4, 3 4s are 12, 2 0, 20. So 3 6s are 18, 2 0, 6 6 6 6 and so on. I'll just write 2 digits after decimal. So I'll round it off to 1.65 Vd. Now let us write this very neatly. Vg, our result is Vg is equal to 1.65 Vd. Now what does this mean? See the question. Question says, how much faster does light travel in glass than in diamond? Answer is, the light travels 1.65. Okay, I'll not say exactly, approximately 1.65 times of Vd, because I have taken a small approximation there. That's it. So Hope you are enjoying the process of solving questions. So let's go to the next question. So next question is, the refractive index of glycerin is 1.46. So right away let us write a given is refractive index of glycerin. I'll write GL as for glycerin, 1.46. The speed of light in air, what is the speed of light in air if the speed in glycerin is 2.05 into 10 power 8. So let us write that velocity in glycerin is 2.05 into 10 power 8 meter per second. We have to find out C. See, you have to know the value of C. Value of C is 3 into 10 power 8 meter per second. This you should know it without calculation, but since the question has been asked, we will do calculation, but our answer will be nearer to this value, that is 3 into 10 power 8. Now let us write the definition of refractive index of glycerin. Refractive index of glycerin will be ratio of speed of light in air and speed of light in glycerin. What are we supposed to find out? We are supposed to find out speed of light in air. So that will be equal to, move this VGL to the other side, this becomes mu GL times VGL. Now since the values are given, let us put them. Mu GL is 1.46, VGL is 2.05 into 10 power 8. Now here you have to multiply it. You can do the multiplication, but I'm again taking small approximation. Instead of writing 2.05, I'm just writing 2, because 0.05 is very small. So I'll get almost right answer, 1.46 into 2. Here I'm not telling you to do it, but I am doing it because I don't like calculation. So 2 6 are 12, 2 4 are 8, plus 1 9, and 2 1s are 2. Now see there, the answer is 2.92 meter per second. Now see the answer here. What is the actual value? 3 into 10 power 8. Actual value of C is 299, 792, 458 meter per second, or if you approximately, it is 2.997, or just approximate it to 8 meter per second. Forgot to write the multiple, 10 power 8 meter per second. Now check here, almost same. So my calculation is good. So speed of light, I'll go with this 2.92, almost same. So right answer. Okay, so let's go to the next question. The next question is, a piece of glass has a refractive index 1.6 and that of diamond is 2.4. Calculate the refractive index of diamond with respect to glass. Now they are asking, now first let us write the given part. Given refractive index of glass is, so I'll write it as mu G 1.6. Refractive index of diamond mu D is equal to 2.4. What are they asking? They are asking refractive index of diamond with respect to glass. So how much will this be? So this is called as relative refractive index. Now let's go with the definition. Okay, let's go with definition, and the result which you are going to get, please use it so that you can save some time. Let's go with the definition first. What does refractive index of glass mean? Refractive index of glass means ratio of velocity of light in air by velocity in glass. What is refractive index of density means? C by Vd. Similarly, now what does refractive index of D with respect to glass mean? See here, the refractive index of glass we have written as Speed of light in air is in the numerator, velocity of glass is in the denominator. So if we come here, refractive index of diamond with respect to glass, we are talking about refractive index of diamond. So the velocity of diamond will be in the denominator, velocity of with respect to what? Glass will be in the numerator. Just we have done this little bit earlier, if you remember. Now how to write this? Let us write like this: Vg by Vd, let us multiply with C by C. C is speed of light in air or vacuum. So C by C cancel each other, it is not going to affect anything, but it is going to change our expression. See how I am writing: Vg divided by C into C by Vd. What is this? What is Vg by C? C by Vg is mu g. So Vg by C is 1 by mu g. Similarly, what is C by Vd? C by Vd, see here, C by Vd is mu d. So what I can write? Mu d by mu g. Remember this result. So the result is mu d by mu g is equal to, first you write refractive index of diamond with respect to air divided by refractive index of glass with respect to air. Simple. So the values are given in the question. Diamond is 2.4 and glass is 1.6. I don't like decimals. I'll write in fraction. I can write it as 24 by 16. So 4 4s are, or we can go with 8 table. 8 2s are, pardon, 8 2s are, 8 2s are, 8 3s are. So the refractive index of diamond with respect to glass is 3 by 2, or you can write it as 1.5, any way you like. So that's the solution of this question. Now let's go to the next question. The question is, a ray of light is traveling from glass to air. So this is important. It is traveling from glass to air. So it is in the glass first, then it goes to air. The angle of incidence in glass is, 35 degrees, and angle of refraction in air is 60 degrees. So let me show that here. Let us take one line here. So let's say this is the interface between glass and air. Where is glass? I'll take it below here. Glass, and what is on the top? Air is on the top. So light, say light enters from, pardon, my lines are not straight. Light enters from glass to air. So here we'll draw a normal. So light will bend away from the normal. Okay. So what is this? Angle of incidence. Angle of incidence should be measured from normal to incident ray. How much is that? 35 degrees. And angle of refraction is 60 degrees. 35, 60. Now you have to find out the refractive index, very very important. Refractive index of glass with respect to air. Refractive index of glass with respect to air. Snell's law states that sine angle of incidence and sine angle of refraction both are constant, and with further experiments, and this constant is equal to refractive index, correct? Sin I by sin R. So the light is traveling from where? Glass to the air. So light is traveling from glass to air. Very important. So sin I is in the glass. Sine angle of incidence is in the glass. Angle of refraction is in the air. So this will be refractive index of air with respect to glass. What is that? Refractive index of air with respect to glass. So if you are observing the diagram from the beginning, when the light was traveling from air to a medium, we have written sin I by sin r is equal to refractive index of the medium. Now the light is traveling from glass to air. Now sin I by sin r will be refractive index of air with respect to medium. So that is the difference. So here we have to find out, we will get sin I by sin r will give us refractive index of air with respect to glass. What are they asking? They are asking refractive index of glass with respect to air. That is the reverse. Now how to get the reverse? Let us understand that. What is refractive index of glass with respect to air? That will be speed of light in air divided by speed of light in glass. Now what did we get? We got refractive index of air with respect to glass, this part. Now what that should be? Speed of velocity of glass divided by velocity in air. See that? If it is not clear, just revise it again, you will get it. So here we are writing with of glass with respect to air, hence speed of air is in the numerator and velocity of glass is in the denominator. Similarly, here we got velocity of air with respect to glass, hence the velocity in the numerator will be of the glass and denominator will be this. Now what is the difference between the two? Both look similar or both look reciprocal of each other, isn't it? Mu g by a, mu refractive index of glass with respect to air is c by vg, and here refractive index of air with respect to glass is vg by c. See that they are exactly reciprocal to each other, so we can write refractive index of glass with respect to air is 1 by mu refractive index of air with respect to glass. So what is this? Sin I by sin r. Hope you are getting it. Or let me write one more step for you. 1 by sin I by sin r. Now the denominator goes to the numerator, sin r by sin I. Remember this result. This result is important. Now let's put the values. All the values are given over there. Let's put them. So what are we going to get? Refractive index of glass with respect to air, that is refractive index of glass in simple words. It is called as, it is equal to sin r. So the angle of refraction is 60 degree, sin 60 by sin 35. Sin 60 is root 3 by 2 and sin 35 is, so don't worry about sin 35, it will be given in question. Sin 35 is 0.574. Now the only thing you have to do is you have to do the calculation. So refractive index of glass is equal to root 3 is how much? 1.732 divided by 2 into 0.574. So we can also write it as 1732 divided by 2 into 574. I'm just removing the decimal places because I don't like it. Hence now what you can do? Solve multiplication and division you have to do. So do it. I am leaving it to you. So do it by yourself. And this value is almost going to be 1.5. Approximately is going to be 1.5. So what is the refractive index of glass refractive index of glass is mu g is equal to approximately 1.5. So with that we completed this question. Let's go to the next question. The question says, a ray of light is traveling from air to water. What is the angle of incidence in air if the angle of refraction in water is 41? The refractive index of water is 1.32. So let us write the given first in the equation. The givens are, number 1, light is traveling from air to water. Okay, so let me draw. This is the interface. Say this is the light. All lines are straight. This is the normal. So incident ray and normal. This is angle of incidence. Now the light will bend. This is air. This is water. Light is going to bend. This angle is R. So R is how much? 41. The question says R is, angle of refraction is 41 degrees. Refractive index of water with respect to air is 1.32. So what do? We use Snell's law. Snell's law says sin I by sin R is constant, and that constant is equal to refractive index. So we want angle of incidence. Sin I is equal to mu W into sin R. Let's put the values. Mu W water is 1.32 and sin R is, I don't know, how much is that? Sin 41. So 1.32 into sin 41 is 0.656. Approximate values, approximated to 3 digits. Now this will be how much? 1.32 into 0.656. This will be approximately 0.866. So sin I is equal to 0.866. So I is equal to, okay, by the way, 0.866, yeah, I can remember this, is approximately equal to root 3 by 2. So sin I is root 3 by 2. Sin I is approximately root 3 by 2. So when, for which angle is sin equals to root 3 by 2? So I should be around 60 degrees. So angle of incidence is 60 degrees. Okay, and also I have written value here. Sin inverse of 0.866 is 60 degrees. Okay, root 3 by 2 is approximately 0.866. You can, if you want, you can remember that. So that's the solution of this question. Next question. The water tank appears to be 4 meters deep when viewed from the top. If the refractive index of water is 4/3, then what is the actual depth of the tank? So here in the figure, please look at the figure here. In the figure, so this is the interface, right? And this O is a point where on the surface, on the bottom, then the distance from the surface to the bottom is what? Real depth. And let us write real depth as capital D. Capital D is our real depth. Real depth. This is real depth. Next. Now what happens? Light from this point moves straight until it reaches what? Interface. At interface what happens? Since this is water, so water is denser medium. Since it is water and light is traveling from denser medium to rarer medium, it will bend away from the normal. It is going to bend away from the normal. So it reaches the eye. but I cannot perceive this bending. What it will do? It will presume that the light is coming from the point. Which point? This point. For I, light seems to travel in a straight line. So the point O for I is here at this point. So for I, or we will presume that here is this is the depth. We'll presume that this is the depth. So water is only deep until here. So that's why we will write this as apparent depth, that is depth visible to us. So I am writing apparent depth as small d. Apparent depth. Okay. Here what are we supposed to find out? Refractive index is also given. Apparent depth is 4 meters deep. Water tank appears to be 4 meters deep, so apparent depth is 4 meters, and refractive index is also given, that is 4/3 for water. I have to find out actual depth. We have to find out actual depth. Now there is a derivation for this, and I don't think that derivation is important for class 10th. Okay, so what I'll do is, it's important for class 12th, but I don't think it is important for class 10th, and I don't think this question will be asked by CBSE. So still we will try to solve this. So for that I'll give you a trick. What is the trick? Refractive index of any medium. Refractive index of any medium is going to be what? Greater than 1. Correct? Because refractive index is equal to speed of light in vacuum or air divided by speed of light in medium. Speed of light in vacuum is greater than speed of light in medium, hence the numerator is larger compared to the denominator. So mu of medium with respect to air is always going to be greater than 1. So from this I am going to give you a shortcut. If see real depth here, in this case real depth will always be greater than apparent depth. You can see the picture. Real depth is always, because of the refraction, if you go to swimming pool, the depth of the swimming pool will appear to be less. That is the practical, you can observe the refraction practically everywhere. So always the depth is presumed to be small. So apparent depth is always less than real depth. Now the formula with this, what I am going to give you is, this can also be proved mathematically, but for 10th class I don't think this is important. So refractive index of medium is greater than 1, d is also greater than small d, that is real depth is greater than apparent depth. So the ratio capital D by small d is also greater than 1, and the capital D by d is equal to refractive index of the medium. So here in this case what will you write? Refractive index of water is equal to real depth by apparent depth. So real depth is equal to refractive index of water into apparent depth. So put the values. Apparent depth, what is this? This is your refractive index 4/3, and apparent depth is how much? 4 meters. So 4 4s are 16/3. So actual depth is 16/3 meters. Or if you want, you can write it as 3, how many times? 3 5s are 15, 1 remainder is 1, 1 0. So 5.333 and so on. So I'll write it only up to 1 digit, 1 decimal digit. So this is 5.3 meters. So now this is the real depth. So the real depth of the water is 5.3 meters and it appears to be 4 meters because of refraction. So if you have understood that, let's go to the next question now. In the next question, we have similar one. A jar of 15 centimeter long is filled with transparent liquid. So if the liquid is transparent, then we can see through it, right? So let us write the given first. So what is given here? The actual depth, real depth, which I am denoting with capital D, is 15 centimeters. And through that I can see the see the bottom of the jar because transparent liquid is poured in it. And when viewed from the top, you can see the picture there, the bottom appears to be 12 centimeters. So this is apparent depth. Okay, apparent depth is how much? 12 centimeters. Actual depth is 15 centimeters. This appears to be 12 centimeters. You have to tell me the refractive index of the liquid. I'll write it as mu L. So right now I have given you the trick. Mu L is equal to capital D by D. That's it. 15 by 12. Centimeter gets cancelled out. So 3 5s are 3, 4s are 5 by 4 is the refractive index. Or if you want, you can write it in decimal too. In decimal this will be 1s are, 2s are, 5s are. So 1.25. That is the solution for this question. This is the end of this video. Thanks for watching, and if you have really enjoyed it watching, learning, then please subscribe the channel and tell it about your friends and family members. We'll be meeting with yet another video soon. Bye bye.